The thing we need to catch up on now is we did some basic, area stuff. We talked about area and the symbol integral that goes with it. So those ideas, we tried to solidify. That was first one. It was the recap from Thursday, the video that I just uploaded. And the other thing that we talked about is what an antiderivative is. And with a little bit of luck, I can kind of summarize this and pick something other than orange today. Let's go purple. If I do the derivative of, let's say, x squared, and I'm going to put some number. Now, the thing that we played with the other day is that we would just x squared plus any number, 5, -3, whatever. The derivative always ended up being 2x. And we all know this rule really well. We take away 1 from the degree. So the degree, you subtract 1 from it, right? That's kind of our derivative rule. It's the degree minus 1, and then we multiply by it, right? So that's our kind of theme to derivatives for the power rule. Well, antiderivatives, as you can imagine, since they're inverses or undoing, we must do the inverse of that. And so we actually do, if you can work through this with me, let's do this derivative x squared plus c is 2x, no matter what the plus c is, whatever, it's a constant, just means a number. If I undo that and I antiderive now, and I take that back, we know we're going to get x squared plus c again, but let's talk about the mechanics of that, because that's where we're going to get our rule from, called the power rule of antiderivatives. Instead of subtracting 1 from the degree, we add 1 to the degree, and instead of this multiplied by 2, we all know that the antiderivative is x squared plus c. The antiderivative of 2x is x squared plus c, because the derivative of x squared plus c is 2x. We're just undoing it. So if we're going to go back to x squared plus c, you realize we add 1 to the power, because it's currently sitting at 1. We're not writing it. We add 1, so it's now squared again. All right, so it's going to be x squared. We got that part. The 2 that we currently have, now I'm going to go ahead and write it here again. This 2, by the way, is a constant. One of the things about antideriving is we can ignore constants at first. It'll take care of itself. But remember, we don't have, our antiderivative is going to be x squared plus c. We've already got this. I mean, we got the answer right here, right? X squared plus c is the antiderivative of 2x, since the derivative of x squared plus c is 2x. And then the key is, how are we going to go from, if the antiderivative, I add 1 to the power, make it x squared, got it, and this 2 tags along, how am I going to get rid of that 2? Well, it actually gives you the other part of the rule, the power rule for antiderivatives. You also divide by 2. And so think of it this way. Derivatives, you subtract 1 from the degree and you multiply by some number. In antiderivatives, you add 1 to the degree and you divide by some number. And the cool thing is we're going to make this real general. And then remember, we don't know what that plus c was, so it's got to have a plus c in it. So let's talk about this in general terms. Your antiderivative power rule is add 1 to the power and divide by it. And that is it. That is all it is. That's the rule. So here's look at that. I added 1 to the power, made it x squared. We divided by 2, because I have to kind of undo this 2 that's sitting here, because we all knew the answer was going to be x squared plus c. If we just add 1 to the power and divide by that power, it cancels away that 2, and it leaves behind just x squared plus c. So if you can see where all that's going, we just need to put that into a real general rule. And that general rule is this. If you are antideriving, let's put it in bright red down here. If you are antideriving, then you're going to go from some x to the nth is antiderived. So let's put it right here. Right here, you're going to get x to the n plus 1, because you add 1 to the power, and then you divide by that same power, is the general rule. And it's kind of the opposite of what we do with derivatives, where we subtracted 1 from the power and multiplied. Now we're adding 1 to the power and dividing by it. The key to watch out for is the degree of your x, and what you're dividing by will always match in your antiderivative. There's also a symbol for this. We put a symbol out there that we just learned last time. It's this. This means take the antiderivative and we throw in this little dx with respect to x. This is the symbol we use for antideriving. And then every time we do that power rule, we also tack on the plus c, because there could have been a constant there. Because remember, we're antideriving. If you want to derive and go back the other way at any given time, you can. If you derive this, it will take you right back here. So, and the plus c just goes away. The derivative of a constant is 0. So that's where we're kicking off. And so let's go to a brand new sheet. I'm going to go to 8.2 in your notes, and I've kind of written on this for another context. Let me clean this off real fast. Let's just start fresh. Got to have a clean sheet. So you guys have this. I shipped it off to you. It's a great place to write our kind of final version of what we just talked about. Let's talk about the power rule of antiderivatives. If we are going to antiderive some x to the nth and dx, that's the real symbolism. That's the real deal. I'm writing in kind of formal terms for you. Then what you're going to get is x to the n plus 1 over n plus 1 plus c. Okay, that's the power rule. Okay, and you can write it on there. This is the power rule of antiderivatives. And it's the biggest one that we use, kind of like the power rule of derivatives. We use that all the time. This is the power rule of antiderivatives. And you're picking up how it's kind of like the inverse. I mean, it really is doing everything backwards. How we deal with powers is we add one to it instead of subtracting. Instead of multiplying by some number out front, we divide by some number out front. Okay, pick up on those patterns and you'll totally get this. It's kind of fun. Okay, there's our power rule. And hey, if there happens to be a constant in front of this, it just tags along. You know, doesn't make any difference. It's all part of it. It's pretty festive looking, isn't it, with that red? Now, let's we got this velocity thing going here as well. So let you see if you can copy that down. You can pause the video if you didn't get that. But velocity, we've dealt with that too. If you undo velocity, you get position. So let's use our power rule. This is it has t's in it. That's okay. We're undoing the derivative. At the end, we're going to put a plus c because there could have been an extra number there that when I derive it, it goes away. But antiderivatives, one piece at a time. You can take t squared. Here's the power rule. Add 1 to the power. Now make a t cubed and divide by that number. These always match. Check, check. Okay, that's important. And then you do the next one, minus 6t. That's going to be 6t to the first. We're not writing that first in there. Might be good as just a starter to remind yourself that's to the first. So now it's 6t squared. You get to divide by 2 because that always matches. Check it out. Make sure these match. What you're dividing by and your new power have to match. Check, check. And then the plus 2, this is the tricky one. There is an unwritten t to the 0 on there. So let's go put that in there. It says t to the 0 we're not writing because that would be 1. But if you add 1 to that power, it becomes t to the first. And then you divide by that same power, which is first. So this is plus 2t to the first divided by 1. That is our power rule for each one of those. And so let me put a little orange in here to that one derive. I antiderive this one and I antiderive that one. I added 1 to the power and then divided by that same thing. And each time I did it, I made sure the new power and what I'm dividing by are the same. And you always finish with a plus c. Big stuff. There's the first time using it. You might ask yourself, do we simplify? Of course. I mean, we did the calculus just now, then algebra kicks in right afterward. It's usually the hardest part. But to finish this one off, just for kicks, let's go over here and write our brand new S of t. Let's keep green going, sorry about that. But our brand new S of t you might even write it like 1/3 t cubed instead of t cubed over 3. 6 over 2, of course, is 3, so that's minus 3t squared. Plus 2t plus c, all that good stuff. That's our final antiderivative. This is our position function. This is undoing our derivative on the velocity function. Now we get our position function. The plus c is a mystery until somebody tells me a point on that graph to pinpoint which, is it plus 5, plus 4, plus 3, plus 2, plus 1, minus 18? We don't know because when we derived it, it went away. So somebody would just have to give you the information or just say c is, c's 5. They could tell you that. So let's do a series of them in a row. Let's do these 3. The only thing that's going to come up on the third one here, are you remembering that f prime of x, if you have a radical, you're going to write it as x to the half, because just like with the power rule in derivatives, it helps if you write all your radicals in terms of their fractional equivalent in exponent form. So I haven't derived that yet, or antiderived. I'm just getting ready. The first couple, let's just put it in practice. If you have f prime and I say find the antiderivative, that means you're getting f. You're undoing the derivative. Your 2x to the third becomes 2x to the fourth, and you divide by that fourth. Your minus 5x to the first becomes 5x to the second, and you divide by that second. Excuse me. Your 7, and now it's not written, but remember it's x to the 0, becomes 7x to the first. You divide it by first, and you add c. So that's good. That's check. We like this one. But if you want to make it really nice, you of course simplify a little bit, and that would be half of an x to the fourth. Simplify your 2/4. 5 halves, can't do anything with that, we'll just write it. And 7x and a c, and we're done. Okay, that's pretty nice from there. The next one, just another run through. Adding 1 to the power. So here's your function, f of x. Maybe I'll change colors so they don't overlap too badly. Let's go purple. And the f of x on this one would be, you do x to the 5th and then divide by that power. That's the power rule in place. It's 3x to the 3rd, now it's 3x to the 4th, and divide by that power. And it's 5x squared, now it's 5x to the 3rd, and you divide by that power. And minus x to the 1st now becomes x squared, and you divide by it. And you kind of getting the idea, the 5x to the 0, it just becomes 5x. Kind of like when we would derive 5x, we'd always get just the number. Now we're looking at just a number. When you antiderive it, you get 5x. And so that'd be a good pattern to pick up on. And of course you finish with plus c each time, because when we drove to get to the f prime, that plus c would have gone away. So you always put a plus c when antideriving at the end for any constant that may have disappeared in the process. Last one. So at the end here, I haven't antiderived yet, but I am now. The antiderivative, add 1 to the power. It's a fraction. Well, don't panic. It just means you take 1/2 and you're going to add 1 to it, and then you divide by that. 1/2 plus 1 minus 4x, because it was just a constant. So it was 4x to the 0, and we're adding 1 and dividing by it. That just becomes 4x, and then plus c to top it all off. This is correct, but it'll definitely need some help. So what you'd like to do is take and add those fractions. So 1/2 plus 1 is 3/2, or you can think of that as 2/2, 2 over 2. And so you can combine those. That's always a common denominator is the way to go with adding fractions. And f of x, you get x to the 3/2, perfectly fine, over 3/2, minus 4x plus c. Looking better, but we can go a step further. When you divide by a fraction, it's multiplying by the reciprocal. So really f of x is 2/3 x to the 3/2 minus, whoops, I forgot my x on the last one, minus 4x plus c. And that's our kind of final super-de-duper, definitely antiderive that one, awesomeness on there. So that was a run through of that power rule.